Self-healing, living concrete, refers to a type of building material that has the ability to repair cracks and damage on its own, similar to the healing process of living organisms. It combines the principles of bioconcrete, which incorporates bacteria to repair concrete cracks, with the concept of self-healing materials. Traditional concrete is a widely used construction material, but it is susceptible to cracks and damage due to factors like shrinkage, temperature changes, and external stresses. Self-healing living concrete aims to address this issue by integrating a biological component into the concrete matrix. The process typically involves the following steps: incorporation of bacteria. Bacteria such as Bacillus subtilis or other types of bacteria are mixed into the concrete during the mixing stage. These bacteria lie dormant within the concrete until cracks or damage occur. Nutrient supply. Nutrients, usually in the form of calcium lactate, are added to the concrete mixture. These nutrients act as a food source for the bacteria. Activation. When cracks or damage appear in the concrete, moisture seeps in and triggers the activation of the bacteria. The bacteria then start to consume the calcium lactate nutrients and produce calcium carbonate, limestone, as a byproduct. Healing process. As the bacteria consume the nutrients and produce calcium carbonate, the cracks are filled with this self-generated limestone material, effectively sealing and repairing the damaged areas. The self-healing process of living concrete can occur multiple times as long as there is sufficient moisture and a supply of nutrients for the bacteria. This process can potentially prolong the lifespan of concrete structures, reduce maintenance needs, and enhance their durability. The development of self-healing living concrete is still in the research and experimental phase, and its widespread implementation in construction projects is yet to be fully realized. However, it holds promising potential for creating more sustainable and resilient concrete structures in the future.